Hey, you guys are being so good and patient. Okay, so here we go. Let's start practicing what we need to do for our learning goal today. So it says sometimes the variable is being multiplied by a constant. We know what a constant is. What is it? That was one of our vocabulary words. What's a constant?
It's a variable.
Is it a variable?
No.
No. It's something that stays the same. So it's a number. It's a value that never changes. So 5 is 5. That's a constant, okay? So when sometimes the variable is being multiplied by a constant, and by the way, constants don't have to be nice whole numbers. They can be fractions like 1/2. 1/2 is a constant. Or being divided by a constant, we're going to use the inverse operation to get the variable alone. So instead of something being added to the variable today, or subtracted from the variable, we're going to have that variable being multiplied by a constant or divided by a constant. So to undo multiplication, what do? We do division, yeah. Now, I am going to make this statement, though. We're going to fill it in. It is division that will undo multiplication. But I'm going to make this statement that sometimes we actually can undo multiplying with more multiplying, and we'll learn that. But typically we say, you know what, well, for sure, the inverse operation of multiplication is division. So we typically use that. To undo division, what's the inverse operation of division? Multiplication. Yeah, so we'll use multiplication to undo dividing. And why do we need to undo? Anybody remember why we're trying to undo? What's the goal when we're solving algebraic equations? What's the final goal? We need to isolate the variable. We need to get the variable alone. It has to be on one side by itself. I think some of you are already going to solving. I'm going to have to make you erase that if you didn't do this, because you know what? We're never going to mess with the original equation. We're going to write it again, and then we're going to start showing its work, okay? So we have 19m equals negative 19. What's actually happening in that one? On the side with the variable, tell me what's going on. Is 19 being added to m?
No, subtraction.
Is there subtraction going on?
Multiplication.
Is there multiplication going on? Is there division going on? There's one of 4 things going on. I was hearing some subtraction. I was hearing some multiplication. We better come to a consensus here. 19 right next to m means what? Leah? It means multiplication. It means m is being multiplied by 19. How are we going to undo that?
Divide.
We're going to divide. So we're going to write out our equation again. And we're going to show the dividing in that step. We're not going to do it at the beginning where the equation was, oh, this is a negative 19 upstairs there. We're not going to do it because we want to know what did the equation start like before we started working with it. So we rewrite 19m and then we show dividing it by 19. We bring down the equal sign, we rewrite negative 19, and we show dividing it by 19. What happens when you take 19 divided by 19 over here on this side? What happens when you take 19 divided by 19? It's just, yeah, it's like they cancel out, it becomes 1, doesn't it? We would have a 1m, and that's what we want. So that we can cancel out, and we could say, you know what, now m is by itself. And now we ask ourselves this question, just like on the Zorna side of the worksheet. What's a negative divided by a positive? A negative. And what's 19 divided by itself? 1. So our answer is negative 1, isn't it? Now, I'm not going to make you do check columns on these. Let's just do a mental math check, okay? If we put negative 1 back into the original equation, so if we took that 19 and multiplied it times our negative 1, what's a positive times a negative? A negative, and what's 19 times 1? So we get negative 19 on that side, and we have negative 19 on the right side, so it would check out. Okay. Now you go ahead and show how you would show work on the second one. And again, remember, we don't mess with the equation in its original state. We write it again, we work with it, and then on the next line, Did you divide by 3? Why? Why do we divide by 3? Because what? Yeah, because the x, the variable, is being multiplied by 3. When it's right next to it, it means multiplication. So since there's multiplication going on, we're trying to undo that. But does 3, now, so, that's the right step, but does 3 go into 5 nicely?
No.
No. So let's ask ourselves this first. What's a negative divided by a positive? A negative. So, once you say that to yourself, now you can ignore it and say, what's 5 divided by 3? Well, you just told me 3 doesn't go into 5 nicely. So here's what we're going to do. We're not going to change this. We're not going to put it into our calculators or do long division or anything. We're going to say, you know what? I can just leave it then as an improper fraction because algebra kind of likes it that way. So we decided that a negative divided by a positive is a negative. We decided 3 doesn't go into 5 nicely, so we'll just leave it as a fraction. But before I circled it, I should have asked you this question. Can 5/3 be simplified, though? Is there something that goes into 5 that also goes into 3?
1.
Other than 1? Because would 1 get us anywhere? No, we still have 5/3, wouldn't we? Is there anything else other than 1? Okay, now, if you gave this answer on your paper, I could not count it wrong. We could say x could equal, what's its mixed number name?
1 2/3.
1 2/3. So if you gave it that way, that would be correct also. That's just its mixed number name. Typically, algebra doesn't necessarily care if you put it in its mixed number name because when you want to do check problems, they work better in their improper fraction name. So I would accept either answer, okay? Here's the answer I won't take. Anybody know what decimal 2/3 is? What decimal does 2/3 represent? What's its decimal name?
60.
0.666. It keeps a 6 keeps repeating, does it not? So here's the answer I don't want to see. I don't want to see negative 1.6 with a repeating bar over the 6. That's not what I want to see. Or here's another thing that I might see in somebody's paper. Negative 1.6666667. You know what I'm going to say to you when I see that? I'm going to say, first of all, you rounded your answer, and I didn't want you to. And second of all, you used your calculator. Why did you use your calculator? Remember, we want to try and stay away from that. Okay, number 3. What's happening to x on that one? What's happening to x on number 3? It's being divided by 4. So we're going to undo division with multiplication. So we are going to multiply this by the same thing. Remember, we're not messing around with it up here. We're going to multiply by the same thing that x is being divided by. That's how we decide what do we divide by. And so both sides are going to get divided by, or not divided by, what am I doing? Both sides are going to get multiplied by 4. So here's the work part. This is what we're doing to it. We're multiplying both sides by 4. The other part of the equation stayed the same. We do it on both sides. Well, here's what happens on the left side. Those cancel out. And we have an x by itself. And now we say to ourselves, what's a positive times a positive? Positive. 4 times 8? 32, yeah. There's our solution. Questions? Okay, you try number 4 now. And remember what I said, don't you dare, work with it as it was. Write it again with your work shown in that step. They're going to look a lot more complicated. Okay, so our step of work was to multiply both sides by -5. And it's being divided by -5, so we want to make sure we multiply by the same exact thing. Is 5 the same as -5? No, it isn't. Okay, so then these guys cancel out. The n is by itself. What's a negative times a positive? -5 times 20? So a -100. That's why we were practicing all of that stuff on that worksheet that we did for today. So that we can multiply and divide like this. Okay. I think you know how to start number 5. Go ahead and start. I think you know how to start it. Give it a try. What should we divide by? Should we divide it by the 5 or the 15?
15.
By the 15. What is 15? I want to divide by the 5. It's a smaller number.
Because it's a variable.
Yeah, because it's what the variable is being multiplied by. So we have to divide by the 15, even though it's kind of tempting to divide by the 5 instead because it's a smaller number to work with, right? We have to divide by the 15. And when we divide by the 15, our 15s cancel. If we had divided by 5, we can't take a 15 upstairs and a 5 downstairs and put a line through them and say they cancel each other out. That wouldn't be true. Oh, what's a positive divided by a positive? Positive. What's 5 divided by 15?
3.
Really? Okay, I want you guys to stop and process this because this happened on a checkup quiz that I did give you back in lesson 1.1. You tried to tell me that 5 divided by 10 was 2. Just like now, some of you are trying to tell me that 5 divided by 15 is 3. 15 divided by 5 is 3. Okay? So could you justify why? Not just because, we know it. Give me a reason. What does dividing really mean? If I'm taking, let's reverse it like Maisie said. You get 3 when you take 15 divided by 5. What's really happening in division? What questions should you be asking yourself? Maisie? So you're taking, so when we're doing the 15 divided by 5, we're saying we're dividing that 15 into 5 groups. And how much would be in each group? There would be 3 in each group, right? There'd be 5 groups of 3. Or another way to say this, if you have 15 divided by 5, you're really saying how many 5s can I take out of 15? How many, think of it as money, how many $5 bills are there in $15? 3. Okay, but now if we reverse it, we have a $5 bill upstairs, and we have $15 downstairs. Can we take $15 out of $5 3 times? No way, good luck with that. So can we even take it out once? Can we take $15 even out once of $5? No, we can't even take it out one time, let alone 3. So what we do is we say, you know what? It doesn't go in there nicely, so I'm going to leave it as a fraction. But then after I leave it as a fraction, I always have to ask myself, is there something that divides in upstairs that also divides in downstairs? 5. So this can be simplified to what? So 5 is divisible by 5, 15 is divisible by 5. We could say this is the same as 1/3. There's our solution in simplified form. Okay? So 5/15, also known as 1/3. Okay. Okay, I really need all of your thinking caps on and your listening skills and everything going right now on this next one because this next one is tricky. And I want it to be a one-step solving problem. So to make it a one-step solving problem, there's a problem with the fact that there's a negative sign out front of our a over 2. Okay? So here's what you need to hear me say. When you have a negative fraction, this holds true in lots of situations. When you have a negative fraction, that means you can give the negative sign to either the numerator or you can give it to the denominator. But you can't give it to both of them. Only one of them can have it. Well, we don't want a negative a in the end. We want a positive a. So who do you think we should give the negative sign to? The a or the 2? Okay, we're going to give it to the 2. We're going to say, you know what? we're gonna rewrite this as A over negative 2. We're gonna give that negative sign to the 2. And we're not gonna mess with anything else. That's the only thing we're doing is we're dealing with that negative sign that was out front. And we're saying, you know what? I can let one of them be negative. I want my A to be positive, so I'm not gonna let it be negative. And I'm gonna give it to the negative 2. Now, A is being divided by or multiplied by negative 2? Divided by, so what are we gonna do? We're gonna multiply, so we're gonna take negative 2 times A over negative 2. We're gonna take negative 2 times negative 4. So again, this is what we're multiplying by. And those negative 2's cancel out on that side. And we ask ourselves, what's a negative times a negative? Positive. 2 times 4? 8. So it's a positive 8. A equals 8. Hey, anybody have any questions about any of these 6 that we worked on the front? Because this is the kind of stuff you're doing in your homework. Now, even if the homework says you check problems, I'm telling you, you don't have to. We did not practice them in our notes, so we don't have to do them in our homework either. I just want you to do the solving and showing this work, okay? Pardon? No. I can bring water to this class, but we're not gonna leave to get drinks, okay? Okay, anybody have any questions about the 6 problems we worked? Not other things. How about these guys? Anybody have any questions about them? Okay, let's go to the back side. We're gonna do one more problem. We're gonna do an application problem. And there's going to be more than one way to actually go about solving this problem, but what I want us to get, I want you to grow in the skill of being able to set up an algebraic equation to help you problem solve. Okay, so lots of times when somebody tosses a problem my way, I attack it as an algebra problem. I say, you know what, let a variable represent the unknown, set up a process, and solve it. Okay, so we have Peter who mailed a package from his local post office in Valley City to his friend in Fargo. The cost was $2.76. So in other words, before he could leave there, they said, give me $2.76. The first class rate was 23 cents per ounce. So if you take something to the post office and you want to mail it, you know, and it's not just a, you know, a regular envelope that you can stick a 49-cent stamp on. What if you have a package that you're going to mail to a friend in Fargo? And you wait at the window. Has anybody ever had to do that? No? Yeah, I just did it to mail something off to my son-in-law who's in Baghdad, Iraq right now. He's deployed over there. And so I had this box of stuff I was sending over to him. So they took it from me. They put it on a scale. They weighed it. And they charged me so much per ounce. And they said, okay, here's what you owe me. $13 and some cents it was. Okay? So I needed, if I wanted to know how much I was actually paying per ounce, I would need to know how much it weighed altogether. If I wanted to know how much it weighed, I would need to know what I paid per ounce. I need to know one of those 2 things. Well, they tell us one of them here. They say, so let's underline this. This is important. 23 cents per ounce, and then the cost altogether was $2.76. So in the end, that's how much Peter paid. When they put the box on the scale, he already knew how much it was going to cost him per ounce. What didn't he know? What did he not know? The weight. He did not know how much the box weighed. So here it says, write and solve an equation to determine the weight of the package. So this is what we're looking for. So we're going to assign this our variable. This is our variable, okay? This is what we don't know. So we get to pick a variable. It can be W for weight, it can be X because X is used all the time, it can be your first initial. What should we go with? Okay, I'm going with W since I'm not really hearing anything. Weight, W is and we have to do this with these problems. You need to tell me what it's standing in for. W is the weight of the package. And you can't be just say the weight because, you know, what are we talking about? The weight of what? Peter's left leg, what's What's the weight of what? Okay, so, you know, the postmaster has put his package on the scale to weigh it. It's 23 cents for every ounce. And the postmaster announced to him, you owe me $2.76. What equation could we set up to represent that? Go ahead and try something on your paper. Something that has that W in there, something that shows that, you know what, you're going to pay 23 cents for every ounce, and altogether pay $2.76. Try something with your pencil. Write an equation down. Okay, who is one that they think, you know, would be might be a good choice? And it's, you know what? We need to feel safe in here that it's okay to give a wrong answer. Because if we give a wrong answer, then we can explore what that would really give us, and we can say, oh, well, then I need to rethink this. So who wants to offer up what they wrote down on their paper instead of me just telling you what it is? Unhandle it? Okay, then I'm just going to come look at somebody's paper and take it. Do I volunteer yet? Holly, what do you have for me? She has, I'm going to write it down though, just so we can look at it. Yeah, I'm not saying you guys have to erase yours and write yours down yet, but this is what Holly has. Let's explore this. So, what's Holly's equation doing? It's taking 23 cents and multiplying times the weight, and whatever we get there should be how much it's going to cost to send it. What do you think? Anybody else got this one? Yeah? You think this will work? Absolutely it will. Way to go, Holly. This is it. This is our equation. Okay, now what are we going to do? Let's solve it. Go ahead, write it down. Now, if you didn't have this one, this is, unless you want to offer yours up, then erase yours and put this one. Let's go ahead and solve it now. What do we have to do in our work step? Divide by what? 0.23. Isn't that what, you know, don't we divide by the 23 cents that the weight is being multiplied by? Okay, does anyone know what we can do when you're dividing by decimals? Anybody know what you can do? Because I say to you, let's try not to use our calculators. What can you do when you're dividing by a decimal? Anybody remember? You can move the decimal point over to make it into a whole number. So we could move it over 2, but if we move it over 2 on this one, we have to make sure we do the same upstairs, so we move it over 2 up there. And what we really have then is 276 divided by 23. How many 23s are there in 27? How many 23s are there in 27? 1. Okay. We're trying to, you know, what's 27 take away 23? 4. So we put that 4 in front of that 6. That's 46. Anybody know how many 23s there are in 46? There's 2, aren't there? So basically what we're doing in class is this right now. I'm just having you do it, trying to have you do it in your head. We are dividing 23 into 276, and we end up with a remainder 0, so we can say the answer is 12. W is 12. But when we have an application problem, we've already done this earlier this year, we don't leave our answer like this, we give our answer as a what? Anybody remember? Sentence answer, yeah. So what was it that we were trying to find? The weight of the package. So could we start our sentence, the weight of the package is? Yeah. So the weight of the package We can write in math too. The weight of the package is 12. That's, I still did let you use the numeric way of writing the numbers instead of word. So 12, but 12 what? 12 pounds? Ounces. Why is it ounces? Was it 23 cents per ounce or was it 23 cents per pound? It was per ounce. So these have to be ounces, don't they? It is. So the weight of the package is 12 ounces. End of sentence punctuation. That's our final answer. That's our circled answer. Okay? So note what we did because you're doing a couple of application problems in the homework. We started by describing the variable. We set up our equation to help us problem solve. We solved our equation. We gave our final answer in sentence form. That's the expectation for the homework then also. Okay? Anybody have questions on this one? Okay, if you have your notes done, you may get started on the homework. If you do not, then we will give you a copy of the notes and you can get a page before you start your homework. So get on your loose leaf paper and make sure you make a good heading.